Working with the reciprocals of the basic trigonometric ratios is sometimes think of as being difficult. In this tutorial, we are going to be seeing the proof of the reciprocals and how we can apply them in questions. To look at the reciprocals of trigonometric ratios, let's start by looking at the meaning of reciprocal. In mathematics, reciprocal is simply the inverse. For example, if you have x, the reciprocal is simply x inverse, and this equals to 1 over x. Similarly, if you have cos theta, the reciprocal will be equal to 1 over cos theta. Now let's clean this off. To clearly define reciprocals of trig ratios, let's look at a right angle triangle. So we have a right angle triangle here. Sorry for the bad drawing. We have r theta with labeling P, Q, and R. So this side is P, the small letter P. We have this side Q, and this side is R. Now we are going to start from the beginning by defining the basic trig ratios. So sin theta is defined as opposite over hypotenuse. And according to this rectangle triangle, this equals to P over R. To define the cos theta, and this equals to the adjacent over hypotenuse. And this equals to Q over R. Defining the tan theta, this equals to the opposite over adjacent. And this equals to P over Q. So these are simply the basic trig ratios: the sine, the cosine, and the tangent. Now to look at reciprocals of these trig ratios, that is the reciprocals of sine, cosine, and tan. Fortunately for us, the reciprocals, they all have names. So the reciprocal of sine is called the cosecant. The reciprocal of cosine is called the secant. And the reciprocal of tangent is called the cotangent. Before, to me, I actually see that this is supposed to be exchanged, but that's just how it is. I used to feel as if the reciprocal of cosine should be cosecant, reciprocal of sine should be secant, but this is how it is. Reciprocal of sine is cosecant, reciprocal of cosine is secant, and reciprocal of tangent is cotangent. So how do we define these reciprocals? So looking at secant, okay, let's start by cosecant, which is the reciprocal of sine. This is defined as 1 over sine theta. Here we are looking at the cosecant of theta. This equals to 1 over sine. And according to this triangle, this equals to 1 over P over R. And this equals to R over P. The reciprocal of cosine, which is secant. Secant theta here will be equal to 1 over cos theta. And this equals to 1 over Q over R. And this equals to R over Q. And the reciprocal of tangent equals to cotangent. So cotangent theta will be equal to 1 over tan theta. And this equals to 1 over P over Q. And here we have Q over P. So these are how we can define the reciprocals of the basic trig ratios. For example, if a question states that sin theta equals to 1 over 2, and we are supposed to find cosec theta. Cosec means cosecant, and that will be equal to 1 over sine theta, and this equals to 2 over 1, and the answer equals to 2. So this is how you can find the reciprocal of the trig ratios. we have the cosecant, the secant, and the cotangent. Okay, by the way, there's a short method that you can use to write the reciprocals. You can simply refer to cosecant as cosec. You can refer to secant as sec, and refers to cotangent as cot. Here we have an example. We have been looking at the trig ratios. We have looked at the basic, which are the sin theta, cos theta, and tan theta. We also look at the reciprocals, which are the cosec, the secant, and the cotangent. Now let's look at an example. So here we have a triangle, a rectangle triangle ABC, and we have to find the first one, which is sin theta. So our sin theta is defined as the opposite over hypotenuse. And according to this triangle, we have the angle in which the side in which the angle is facing is referred to as the opposite. The longest side is referred to as the hypotenuse, and the last side is called the adjacent. So according to this triangle, we have the opposite to be 5 over hypotenuse, which is 13. The second one, which is cos theta. Cos theta is defined as adjacent over hypotenuse, and this equals to the adjacent equals to 12 over hypotenuse equals to 13. The third one, which is the tan theta. Tan theta equals to the opposite over adjacent, and this equals to 5 over 12. Now, just like a sidebar, we should note that, let me draw just a box here. We should note that tan theta equals to sin theta over cos theta. So to prove this, we already have our tan theta to be equal to 5 over 12. Now let's check if we divide cos theta by sin theta, whether we are going to have the same thing. Sin theta according to this equals to 5 over 13 divided by cos theta, which equals to 12 over 13. This is 5 over 13 multiplied by 13 over 12. And this we cancel out, so to have 5 over 12 as our tan theta. So we can see here that tan theta equals to sin theta over cos theta. So let's clean this off. So let's continue by looking at the remaining part of the question. So the third one is sec theta. The fourth one is sec theta. So we have made known that sec theta is the reciprocal of cosine, and this will be equal to 1 over cos theta. Sec is coming from secant, which is the reciprocal of sine, of cosine, 1 over cosine. So since we have our cos theta to be equal to 12 over 13, here we have our sec to be equal to 1 over 12 over 13, and this will be equal to 13 over 12. So that is sec theta. The fifth one, the E part, which is the cosec theta. Cosec theta is the reciprocal of sine, so this equals to 1 over sin theta. So this is 1 over 5 over 13. 5 over 13 is our sin theta, so we have this to be equal to 13 over 5. The last one, cot theta. And cot theta is the reciprocal of tan, so this is 1 over tan theta. And this equals to 1 over 5 over 12. And this equals to 12 over 13. Wow, that is 12 over 5. And that's simply how we can find our sec theta, cosec theta, and cot theta.